When thinking about optimization in software engineering, keep these two principles in mind. 1. Don't do it. 2. Don't do it yet. At first, this principle sounds strange. Software engineers care a lot about performance. We want programs that run fast and use fewer resources. But over time, developers realize that optimizing too early often causes more problems than it solves. Let's walk through what this means. When you start writing a new program, your first goal is to make it work correctly. You want code that is easy to read, easy to test, and easy to change. At this stage, you usually don't know where performance problems would appear. Imagine you are building a small app that keeps a list of 1,000 users. You need a function that finds a user by name. The simplest solution might look like this. For each user in users, if user name is equal to name, return user, else return none. This code goes through the list one item at a time. It is simple and easy to understand. Now, someone might say, wait, this is not the fastest method. What if we build a complicated search structure or a special tree so the lookup is faster? But with only 1,000 users, the simple loop might take a few milliseconds. The user will never notice. If we replace it with a complex system too early, we make the code harder to understand and harder to maintain. We also spend time solving a problem that might not exist yet. This is why engineers follow the first principles. Don't optimize immediately. Focus on the clarity first. Now, let's talk about the second principle. Don't do it yet. This principle becomes more important when your program grows. Suppose your app becomes successful. Now, instead of 1,000 users, you have 2 million users. Suddenly, that simple search function is slow. It might take several seconds to find a resource. Now, optimization makes sense. But even at this stage, guessing where the problem is doesn't help. The best approach is to measure it. Profiling tools help reveal where the program actually spends most of its time. Sometimes the slow part is exactly where you expected. Other time, it might be somewhere surprising. The take-home lesson is this. First, write simple code that works. Second, make sure the code is correct and easy to understand. Third, measure performance with real data. And finally, optimize only the parts that are truly slow.